Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you SLR parser. SLR stands for Symbol Left Right Parser. Okay, so last few video class I taught you types of parser, that is recursive descent parser, predictive parser, shift reduce parser and operator precedence parser. And these parsers are example for top-down parser. And this is the example for bottom-up parser. Okay. So what is the difference between top-down and bottom-up? I already told you. Bottom-up means we will take during stack implementation, we will take input as in a stack, and then we will obtain start symbol. Okay. Bottom-up parser, we will take start symbol and we will obtain input. Okay, clear. So this is SLR parser. So there we have few steps to understand, that is augmented grammar. First one is we have to find augmented grammar. Augmented grammar. Okay. Second one, we have to find I function. That means item. I stands for items of all the augmented grammar. Okay. So that I will teach you. And third, we have to find SLR parsing table. SLR parsing table. And then we want to find stack implementation. Okay. So in all the parser, we found parsing table and stack implementation. But this is SLR, so we have to find SLR parsing table, that is something different than previous parser. And stack implementation also different than the previous parser. Understand? So these 4 steps you have to remember. First one, we are going to find augmented grammar. Then items of all the function, and then SLR parsing table, and then stack implementation. Okay. So here items means we will find the closure. Okay. So during the problem I will teach you. Let's take one small example grammar, that is s tends to L equal to R slash R, L tends to star R slash ID, R tends to L. Okay. So we have to construct star equal to ID, this function, for example. So whether we can derive this star equal to ID from this grammar? Yes. How we will find? Based on the derivation. Okay. Right. So in SLR parser I told you, first we have to find augmented grammar. Augmented grammar. How to find augmented grammar is, which one is, we want to see which one is the start symbol. So which one is start symbol? S is a start symbol. So we can rewrite the grammar like S tends to L equal to R, S tends to R, and L tends to star R, and L tends to ID, and R tends to L. So we can rewrite the grammar like this. Yes, clear? How? Because slash is separated these two production. So we can rewrite the grammar like this. So augmented grammar, we have to see the start symbol. S is the start symbol. So you have to write S dash tends to S. Clear? S dash tends to S. So even if it is E is a start symbol, how you are going to write this? E dash tends to E. Okay, this is the rule to find an augmented grammar. S dash tends to S. Why I written like S dash tends to S? Since S is the start symbol. Suppose E is a start symbol, E dash tends to S. Then you have to write the grammar. S dash tends to S, and then S tends to L equal to R, and S tends to R, and L tends to star R, and L tends to ID, and R tends to L. Okay. So then in this grammar you have to put dot to the previous of the first production. Clear? This is the augmented grammar. This is called as augmented grammar. So once again, how I return augmented grammar is, S is a start symbol. So I have write like S dash tends to dot S. That means S, previously you want to put dot. Okay. And S tends to dot L equal to R. The same, after S dash tends to S, the same production I written. So this is called as augmented grammar. Clear? Augmented grammar. And then why we are putting dot is the function which represents the end of the production. During a problem construction, you can clearly know. Okay. Okay, right. Augmented grammar is like this. Second one is, I told you, we have to find the I function, that is go to function. Clear? So we will take this as item 0. We'll take this as item 0. This function is augmented grammar function is item 0. Okay. So we want to find I1. That is, we have to see, or we want to write I1 later, because if the obtained function and this function is same, we want to write I0. If it is a different function, different grammar we will write I1. Okay. So now first step is go to of I0 comma, we have to check the dot near to the variable. Okay. So we want to find go to function of S, go to function of L, go to function of R, go to function of star, go to function of ID, and go to function of L. Clear? So first we have to see go to of I0 comma S. Why S? I0 comma S. Why S? Because dot is present near the S. Okay, in item 0. So we will write like this: go to of I0 comma S. So what I want to do is we are writing S dash tends to S dot. This dot we are writing after the function. Okay, we are moving one step afterwards, right? One step forwards. That is dot S. It is converted into S dot. Clear? We have to check whether any S is present. Another dot is present near to the S. No, only one. So this is the obtained function. So I will mark this as I1. Mark this as I1. Clear? And then second step is go to of I0 comma S is over. Then we have to write L. Go to of I0 comma L. Okay, I0 comma L. We want to check where L is where dot is present near L in I0, because I0 comma L. So L is present here. See, S tends to. So S tends to this production. S tends to dot L. So how we want to write L dot? Clear? L dot equal to R. Equal to R. There is another one function dot L dot is present near L. That is R equal to dot L. So we have to write R tends to L dot. L dot. Clear? L dot. See, suppose if the dot comes near the variable, I will tell you what we want to write. But here the dot, after moving the dot, it comes near the terminal. Okay. So then third step is go to of. Tell me, we finished go to of I0 comma S is over, L is over. Then another dot present near R. Go to of I0 comma R. I0 comma R. Okay, so what we want to do, we have to check in I0 where dot is present near R. See, only one function is there. This is not, dot is not present near R, dot is present near star. So, only one function is there. So, I will write S tends to R dot. S tends to R dot. So, this is different than this I0. So, I will put I1. This is also different than I0 and I1. So, I will put I2. This is also different than I0, I1, I2. So I mark it as I3. Clear? I3. Then fourth step, tell me go to of I0 comma R is over. See, S is over, L is over, R is over. Then another one is ID. Sorry, star. Go to of I0 comma star. See, listen very carefully. This is very important. So the dot is present near star. So what I want to do as usual, L tends to star dot R. We are moving one step forward, we are moving dot one step forward. So star dot R. Okay. Now dot is comes near the another one variable. Very important. See, here I moved dot is not comes near another one variable. Okay. Here also dot is not comes near another one variable, since this is a terminal. Equal to is a terminal. Here over. Okay. But now when I move the dot, it comes near another one variable R. Variable R. So what we want to do is, this is the rule and algorithm. What we want to do is, we have to write R function, R production in I0. R production in I0. See, where R is here. Okay. So we want to write R tends to dot L. Dot L. If I write dot L, another dot is present near variable L. So again we want to write L function of I0. Okay. So I will write L tends to dot star R. And L tends to dot ID. Clear? Once again, see, when I move the dot one step forward, it comes near one variable, that is dot R. It comes near variable dot R. So in this case, what we want to do is, we want to check I0 in this R. Okay, since it is a variable, so we want to check I0 R. I0 R is R tends to dot L. So we want to write R tends to dot L. When I write R tends to dot L, again dot comes near another one variable L. Okay, so again we want to see the I0. So we want to write this to L function. Okay, so this grammar is different than I0, I1, I2, I3. So I will mark it as I4. I will mark it as I4. Clear? Okay, now fifth step is, see which S is over, L is over, R is over, star is over. Again dot comes near ID. So we want to write go to of I0 comma ID, I0 comma ID. So what is our procedure? We have to move dot one step afterwards. That is L equal to ID dot. L equal to ID dot. Okay, so whether this is the same as like I0, I1, I2, I3? No. See, I0 is this, I1, I2, I3, I4. This is different than all previous items. So we will mark it as I5. I5. Okay. Again, see the I0 is over because I moved all the dot function one step afterwards. Then we have to check I1. Whether we want to move I1, already dot is present after variable yes. Okay. No need to move I1. So no need for I1. Then again we have to check I2. Yes, we have to move dot one step afterwards. So I go to then sixth one is go to of I1 is not there, I2 comma dot is near equal to terminal. So I2 comma equal to. So we want to take this one. So S tends to L equal to dot R. So since when I move equal to the dot is comes near one variable. So what we want to do, see, listen very carefully. What we want to do, we have to write R, production R where? In I0, not in I1, I2, I3, I0. This should be very careful. Okay, if I move dot and it comes near the variable, we have to write R, this variable in from I0. So I0 R here, R tends to dot L. So again L is there. When I move dot right, R tends to dot L dot comes near L. So I have to go for again L function in I0. So L equal to dot star R. L equal to dot ID. Clear? We have to check whether, see here when I write this is terminal. So I am not going for this one. Okay. When a dot comes near variable, you have to write I0. Okay, it's now whether we have to check whether this is the previous item. No. So I will mark this as I6. So summon I2 over I3. Whether I want to move dot in I3? No. Already dot present last. Then I4. I have to write L tends to R present dot present near R. Okay. So go to of I4 comma R. Okay, since dot is present near R, I4 comma R. So I will write it like L tends to star R dot. Okay, star R dot. Right? Again, whether R is there? No, star R dot. So over. And we have to check whether this is the whether this is old function or a new function. This is star R dot is not there. So I will write it as I7. And step 8. Go to of, see R over, again L is there. So which one? I4 comma L. Then what I want to do, R tends to L dot. Check whether this is the previous one. No, new one. So I have write it like I8. Okay. Then ninth function, go to of I4 R over L over. Again star and ID is there. So go to of I4 comma star. See, I will write L tends to star. I move one step afterwards. So the star L R. Since this is R, I am going to write R tends to dot L. Since dot comes near L, I am going to write this two function in I0. So L tends to dot star R and L tends to dot ID. Okay, dot ID. So check whether this is the previous one or new one. See, already is there, I4. Clear? See, listen very carefully. L tends to star dot R is already in where? in I4. So what we want to do is, again this is not marked as I9. If you mark as I9, it goes infinity. Okay, since this function, this grammar and this grammar is same, you have to mark I4. Okay, I4. Again you have to check, go to of I4 comma ID. So it comes like go to of I4 comma ID. Again the same procedure. Okay, so hope you will get item 9. Till 9 you will get. Okay, how you are where you are stopping? See, this is over. Then you have to check this no need. Again then you have to check this, go to of I6 comma R, because not dot is present near R. So again one item we will obtain. So you have to check that is previous or the same. Again you have to go for this, no need to go this also over. Again this. Okay, if you get the same item, then you want to mark it as the previous item name. Okay, so this is the go to function, that is the second function. Okay, so next video class I will teach you. So in this SLR go to function, you will get I9 till I9. Okay, you work out and you just see our notes till I9 you will get. So next video class, this continuity, that is the SLR passing table, I will teach. Okay, thank you.